Oh, actually, I'll wait till the recording starts. All right. It's Tuesday. This is day 2 of 5.04, converting equations. Yesterday, we converted points. Today, make sure you have your unit circle out, your identities formulas from last unit in front of you on your computer or printed out. We're going to use those, but I should have those on the screen too. So maybe you shouldn't need that. And maybe some graph paper, some polar graph paper, and some Cartesian, just standard graph paper. We'll be using those as well. Or you can use Desmos. All right. Also, I want to say that next week is AZ Merit testing. So it's going to be starting April 5th all week and then the following week. So I will be proctoring both weeks. So that means we will not have our live sessions as normal. What I'm thinking about doing is rather than just record everything and just put them up there, after I'm done proctoring and I come home, I'm thinking about maybe just having live classes at 4 o'clock. So it'll be at the end of the day. I know you guys may have plans, other stuff going on, and that's fine. So I think people that are here and want to show up for the live sessions can show up at 4 p.m. starting Monday, and it'll just be for that week. I think that'd be better. That way, people that like showing up can get that still, and it'll be recorded, of course, and then they'll be put up. But I think that works for me. If it works for you guys, and if it doesn't work for you, sorry, that I have no other choice. You should know if you're taking the AZ Merit because someone called you to confirm your testing location. So you should know. You should know. All right. So what else? And because of AZ Merit testing, starting Monday, the lessons that we're going to have will be for that entire week. We'll have a new lesson every day of the week. But then the following week, those lessons will just repeat. So we're not going to have 2 weeks of new lessons. We'll have 1 week of new lessons. The next week, they'll just be repeated so people can, I guess, get caught up that week. And then the week after that, the lessons will continue after where we left off on that week, if that makes sense. All right. All right, we're being recorded, everyone. Okay, make sure you snip this page or write down the notes. I think writing notes is better, actually, but that's just my opinion. You do what you want. We're going to use all of these. So what I have boxed is, well, the important piece that you need to take out of this. And I should actually have this on every slide that we use this. But these are just like the conversions and to go from like polar to rectangular and vice versa. So the first one is x squared plus y squared. Well, that equals r squared. Now, if you think about it, if you were to graph on a unit or on a circle, and you had the x distance, the y distance, well, remember the radius is the hypotenuse, so it kind of makes sense that it's Pythagorean theorem. So when you convert equations and you see x squared plus y squared, this can interchangeably be turned into r squared and vice versa. So we'll be using this one. We'll also be using the identity that tan of theta is y divided by x. So we'll be using that, vice versa. And the other two would be these. So x is equal to r cosine theta. So whenever you see x, you can replace x with, well, r cosine theta if you're trying to go to polar, and vice versa. If you're trying to go to rectangular and you see r cosine theta, you can replace this piece with, well, x. And then the y counterpart is the same as if it was the x, but with, well, sine instead of cosine. All right, so let's do a few. So I have a total of 9 examples today. If you're kind of wondering, I know. I like to know how long something is and how many examples we have. I don't always tell you guys, and nobody always asks. So, well, I'm telling you today. So we have 9 examples to work through. So here's the first 4. All right, we want to go from rectangular to polar. I'll give you a moment just to write these 4 examples down, because after this page, I'm just going to show one at a time. But for people that are very quick, you may want to write these 4 down so that way you can work ahead if you'd like. All right, let's look at number 1. All right, whenever you have a problem, now looking at this, now think back to last semester. I don't recall what unit it was, but we did this last semester. This is a conic. This is from the conics unit. What conic is this equation? Anybody remember? Go ahead and say it in chat if you remember what that equation makes. What conic? Now, remember the conics would be like parabola, hyperbola, circle, ellipse. I feel like I'm forgetting one. Maybe that's it. Circle. Yes, this one is a circle. Now, a parabola would be like y equals x squared. That makes a u, whether it's opening up or down, that would be a parabola. So this is definitely not a parabola, but this is a circle. So you have x squared plus the quantity squared equals 9. Now, what is the radius of the circle based on that equation? Nice job, everyone who remembers. Yep, square root of 9 is 3. So the radius of that circle is 3. Yep, very good. All right, so to convert from rectangular to polar, and you have like a binomial squared in this case, you have to multiply it out. So we need to FOIL it. So everyone on your paper, everyone, I'll give you 1 minute to FOIL that out and simplify it. I am not going to show the work for that. But all of you in pre-calc is more than capable to FOIL that binomial. So if you forget, remember, write it twice, and then, first, outer, inner, last. So 1 minute. Ready to go. When you are done, give me a green check mark so I know you are done.
Really random, but when I said parabola, I was actually saying the one I think you missed of the conic.
Oh, thank you. I think I did miss that one. All right, time is up. If you're still working, but you're here, just give me an X, so at least I know you're here. Sarah, you tabbing back in, join the class. Thank you. Jacob, tabbed out. I see you. All right. And chat, go ahead and write what the simplified foiling of that binomial is. So y squared minus 6y plus 9, Emily says. All right. So we FOIL that out. There's my FOILed expansion. And then you want to obviously combine terms. So like you said, the negative 3y minus 3y, that's negative 6y. In the same step, I'm going to subtract 9 both sides. That's how I get that 0 here. So when you're to like this step here, you want to make sure your x squared and y squareds are side by side. So let's say you had to FOIL out like x stuff to get an expansion, like we did with the y stuff. When you rearrange your terms, even standard notation, you always want to have the square stuff first, and then descending, right? So you have your x squares, your x's and y's, then your constants. So it so happened it was already put in that order for us just by luck, right? Now from this step, we want to convert from this rectangular form to polar. What can I do? And you want to use this list of stuff here that helps us convert. What can we do? Now remember, we're not solving for rectangular. We're converting stuff. So looking at this box, this is the conversion. This is the conversion to go from rectangular to polar, rectangular to polar. Well, this would be polar to rectangular, and this would be rectangular to polar, rectangular to polar. That's what that box is. All right, Julia says replace the x and y for r cosine theta and r sine theta. Yep, so that's one thing we could do. No one's stating the obvious one. Oh, wait, yeah, they are. Okay, I see it. Somebody, Julia said, yes. X squared plus y squared becomes r squared. So you notice that we have x squared plus y squared right here? Well, to convert to polar, we are converting. We just replaced this, with what it equals to. So x squared plus y squared becomes r squared. So we replace that. All right. And then Julie also said that, so once you take care of the x squared plus y squared, all we have left is the minus 6y. So the y we know becomes r sine theta. So replace the y value with r sine theta. Everyone in agreement? All right, so again, x squared plus y squared became r squared. Then we have your minus 6 times y, and the y becomes r sine theta. Are we good so far? Well, we know the radius is 3 once you graph it, but that is irrelevant when actually converting. All right. So next, we want to solve for r. So looking at this, r squared minus 6r sine theta equals 0. How do I solve for r? Factor out r. Okay, nice. Yeah, we're going to solve by factoring. So we're going to GCF, greatest common factor, and r out. And we get this. So far, so good. All right, now what? Set both equal to 0. Yeah, so once you factor, remember solving by factor, you factor it, and then you set the factors equal to 0. All right, so we have r equals 0 for the first one, and then r minus 6 sine theta equals 0 for the second one. This one's already solved for us, so that's why I just went ahead and just highlighted that as being an answer. All right, and then to solve that second equation, to solve for r, what do I do? We're solving for r. Yeah, so we are just adding 6 sine theta to both sides, right? Remember, our goal here is to solve for r. So in rectangular form, we want to solve for y. Y equals some equation, right? Well, in polar form, we want to solve for r. So r equals some stuff with theta, if you've forgotten or didn't know. And then we are done. So one thing I want to point out is radius. So remember, I think it was it Friday? Yeah, Friday last week. We talked about like the 5 or 6 different types of polar graphs. And when you have r equals some number, what does that make? What kind of shape? A circle, yeah. Can you have a circle with a radius of 0? Yeah, the answer is no. So most books, even like learn modules and your quiz and your test, even though we got r equals 0, because it's a circle with a radius of 0, they actually don't include this answer. So I'm just going to go ahead and cross it off, because really r equals 0 would just be like basically a point, and well, that's not an answer when converting it. So most books, text won't include that answer, so I am not going to include it either.
I have a really quick question.
Sure.
If we know the radius is 3 because of square rooting on the original equation,
Mm-hmm.
why do we have to solve for r?
So let me ask you a
Like in
question.
the 6r sign.
Right, and that's a good question. So looking at this, we can see that we have an x, a horizontal shift of 0, and we have a vertical shift of up 3, correct?
Yeah.
And a radius of 3. Are you able to go directly from this, using this shifting directly to this? Can you pick out that, hey, this equation gives us a circle that has a vertical shift of up 3 and it has a radius of 3? I can't. Doesn't mean you can't, but I definitely can't. So and so
No.
so so I'm answering. So basically, I'm answering your question with the question, and the answer is probably not, right? So that's why we have to solve to derive that equation. Um, and maybe if you do enough of them, you might see a pattern. You might be able to go right from rectangular, if it was a circle, to this form. Maybe. I don't think I could, unless I did
Okay.
like maybe like 100 different examples. So hopefully that answers your question.
Okay, thank you.
Mhm. And then let's graph them both. So a cool thing about converting from one to the other is when you graph them, like I did here in Desmos, you will get the identical graph. Check that out. We have a horizontal shift of 0 and a vertical shift of up 3 units, and both circles have a radius of 3. How cool is that? That's pretty cool. And in Desmos, this is how you would type both of them out. In Desmos, you would just type this out, hit enter, and it would draw this sweet circle. And then we would, in the settings, we would change the graph to polar. That's easy to find. And then you would just type in r equals 6 sine. And to get theta, all you have to do is type in the word theta, Theta. And then Desmos will automatically convert that word into that symbol. How cool is that? I think it's pretty cool.
On the test, will it only ask for that r equals 6 sine theta? Like, will we
Yes.
have to put, okay.
Down 3. Hold on. What do you mean down 3? I think are you, I don't, what's the context between, because the minus 3? Are you talking about the rectangular here? The shifting rules? Remember, it's opposite. So because it's, well, remember, it's y minus k, and it's opposite. So we're not going down, we're going up. So your k value is 3, so that's why it's a vertical shift up 3. Oh. All right. Shall we go on? Oh yeah, and then this little note, use Desmos. Do not use GeoGebra this unit. GeoGebra can't do this. So if you are a fan of Desmos, perfect. If you are a fan of GeoGebra, sorry, switch to Desmos. I know, GeoGebra can't do this. Yep. Yeah. Get out, right, Caitlin? Get out. All right. So on your quiz, on your test, and you convert from one to the other, graph them both. It's an easy way to check your answer because if they match, you did it right. If they don't match, something's wrong. Graphing is an easy way to check your answer. All right, let's look at this one. And obviously, I have a lot of blue boxes, which means I probably have a lot of steps, but not really. These last steps here are just making it look nicer. But let's convert this from rectangular to polar. In chat or on the mic, ideas of what we can do first.
I have a dumb
So
question.
you could multiply by 3 first. That wouldn't mess anything up. I don't do it first, but you can. Yeah, Antonio, what's your question?
Can we just use this one since it looks similar? We probably can't put the X
Well,
on top.
right. For you to use that one, you'd have to have y on top, x on bottom. But it's a good observation for sure. And Antonio, I would try to make it look like this. I think Antonio, you're under the right step. You can, but you don't have to. I don't think I didn't do it that way, but
So if
I kind
the X
of
is on
like
the
that
top,
idea.
So the 3 was on. Wait, can we just flip these? Will that help anything? Just do your trick.
No. Well, remember, y is over 1, so you can switch the 1 and the x squared. So actually, this problem has more than one way to approach it. And Antonio, the way you're trying to approach it is fine. I don't do it that way. But yeah, so you can swap the 1 on the bottom of the y with the x squared on top. And that will be fine. And that will give you y over x squared, which will allow you to use this. And I feel like your way, Antonio, might be faster than my way. At the end of the class, if I have time, I'll come back to this one and I'll try it your way because I think your way actually might be faster when I think of it. But what I did was I just replaced x and y with what they're equal to. That's what I did. I took the obvious choice. But I think Antonio's way might be a little faster than mine. I really wish I could add pages to this. And yeah, but it's okay. Let's replace y and x with, well, what it's equal to convert to polar. So, well, y becomes r sine theta, and x becomes, well, x sine theta. I'm sorry, r sine theta. Saying everything backwards. X becomes r cosine theta squared. Yep. And what Julia says, you have to square it. So if you are squaring r cosine theta. What should I write this numerator as in this step here? They're power rules, guys. This is r times sine theta. All raised to a power. Pow, multiply now. Power to a power, multiply. Nope, you're thinking of logs and natural logs, Antonio. There you go, Chloe. Yeah, r squared times cosine squared theta. Yep. Yep. So you are squaring the r and you're squaring the cosine. All of you should know your power properties. If that was like a times b all raised to the second power, would you know to write it as a squared times b squared? If you saw it in that form, would that make more sense? Okay. So what I do when I think of, oh, how do you do this? Think of an easier case like that, because this is r times sine theta. This is a product, something times something, like a times b. Both raised to the second power. You're squaring the a, you're squaring the b. So it makes sense. You would square the r, you would square the sine. Welcome, welcome, welcome. Better late than never. Okay, next, what can we do? So remember, our goal is to solve for r here. So what can I do next?
Can we factor out an r like we did last time?
How would I do that? Because I have r on the left side and I have a fraction on the right side. How would I do that?
True. Oh, I got it. Okay. Flip this thing to the bottom, like you were doing it earlier. So put this over here.
Might work. Emily says divide both sides by r. Yes, we could do that. I'll give you a hint. Let's get rid of our fractions. Let's make it easier to look at.
Multiply both sides by 3.
Yep, multiply both sides by 3. Yeah, and this just makes it easier to look at. In the very beginning, we actually could have cleared our fractions here by multiplying both sides by 3. And that may have made it look easier. I waited till now. Again, these problems, there's more than one way to approach them, and this is just how I did it. All right, Emily, now what's the next step? Divide by r. Yep, divide both sides by r. All right, now what? Remember, our goal is to solve for r. Is solving equations hard in pre-calc? Divide by cosine squared theta. I would agree with that. Divide both sides by cosine squared theta. And that will get r by itself on the right-hand side. Right? How can I write cosine squared? Without writing it as cosine squared, how can I write it so I don't have to see the power of 2? I'm asking the question really weird. Don't use your identities. So that's what I'm not hinting at. And I was thinking that some of you might think about that. I just want to rewrite. I still want cosine, but I just don't want to see the squared. How can I write it without using identities. Yeah, so it's, yeah, what Emily says, it's just cosine theta times cosine theta. I'm just writing it expanded, just, well, it's going to be easier to look at. And you don't have to do this step. If you're good about like maintaining squares and non-squares in your head and how they work, it's fine. I think it's easier to look at it without powers, because even though if we type this into Desmos and you hit enter, and then you type this in and hit enter, these graphs would be the same. So we're sort of done right here. It's just not simplified yet. And that's what this column is. We're going to simplify it further. So looking at this and using our identities, how can I change my trig stuff to make it, well, less trig writing? You guys want a hint? Want a hint? Please, please give me a hint. Give me the answer. Look at sine theta and cosine theta. Use sine theta and cosine theta. And think of your trig identities.
Tangent.
Tangent, yes. It is tangent, yeah. Sine theta divided by cosine theta equals tan theta. All right, so that's what it becomes. Sine divided by cosine equals tangent. So that's what I rewrote it at. So look, now it's looking like I'm writing less trig stuff, but we're not done yet. Let's try to make this without any fractions. So how can I rewrite that cosine as something else? How can I write that cosine as something else? Secant, yeah. So I rewrote just to show it's the same thing. I just kind of pulled it out just to show that it's 1 over cosine, right? And 1 divided by cosine becomes everyone together, it becomes secant theta, yes. And we have no fractions. I think we condensed our trig answer down to, well, the simplest form. And I'm just going to rewrite it with r equals that stuff. So now, when you go into Desmos and you type both of these in, as shown here, rectangular form is this graph, and then I type this into Desmos, just as you see it, and I get this. Remember, to get theta, you just type in the word theta, T-H-E-T-A, in Desmos, and it'll automatically convert that word into that symbol. And if you typed it correctly, you will get this. And then it's a great way to check. This graph equals this graph. How cool is that? I think it's pretty cool.
Dr. J, can you go back to the last slide really quick, please?
Sure. Your mic's still on, by the way.
Sorry, you could go. You could switch
All
the
right.
slide.
Okay, so any questions on this example? If these take practice, so again, you should be going through the modules, the learn and practice, doing the examples, The more you do these, the easier they are. And you should have had practice basically converting, from here to here. This was, I don't know if it was unit 3 or it was unit 3 or 4. I don't remember. It all kind of blends together. Unit 4. Okay. Unit 4. So all of you should have had practice going from this to this. Like, I've seen examples in the modules when we did some. So all of you should know how to do this. It's not going away. Okay, rectangular to polar. Y equals X. What should we do first? Well, actually, I'll tell you what. Let me give you 2 minutes to. Well, let's do a minute. Let's do a minute to think about it and start this problem. And whatever you think you should do, go ahead and try it on your paper. I'll tell you what. I'll even show you the answer so you can see if you can get there. All right. Does anyone try to guide me through this problem on mic? Danica answered for everyone, no.
Okay, I only got one recommendation. After that, you're lost because I'm stuck.
All right,
You
Chloe,
want
you
it?
want to try to
right.
explain? Chloe said she has it. I don't know if she wants to go on mic or not. Just kind of maybe explain your thought process and what we do first.
Can you hear me?
Yes.
Okay, so what I did first was I put the y into r sine theta, and then I made the x r cosine theta. And then I divided by sine theta on both sides, which made r equals r times cotangent theta. And then I divided by r to get 1 equals cotangent theta. And cotangent inverse of 1 equals theta. So, and on the unit circle, I found that theta equals pi over 4 or 5 pi over 4.
I did it
Okay.
different. Can I explain how I did it too?
I think you told me backwards. Did you say you divided both sides by sine or cosine?
I divided both sides by sine.
Okay. So, and then you divided both sides by r, correct? And you got 1 equals cosine over sine, right, Chloe?
Yeah, but I rewrote cosine over sine as cotangent.
Right. So, oops. Let me try to. So the way you did it was perfectly fine. So you divided both sides by r. You got 1 on the left side. Cosine over sine became cotangent of theta. And then what did you do?
Cotangent inverse of theta,
Okay.
or cotangent inverse of 1 equals theta.
Right. So yeah, so she did the arc cotangent both sides, and then that's how she got theta. Oops. She got the arc cotangent equals theta. And then what'd you do? My Euro's terrible.
I found on the unit circle that it's pi fourths and 5 pi fourths.
Right. So with cotangent, remember, tangent is y over x, and cotangent is x over y. So you have to find that combination where x divided by y equals 1. And the good thing is, if you mess that up and you still say y divided by x, well, you can't mess it up because it's going to equal, it equals 1, right? So there's 4 places where you can either get 1 or negative 1. So I would recommend try to avoid using cotangent, cosecant, and secant if you can. And so, Chloe, if you would have divided both sides by cosine instead, you would have had sine over cosine, which became tangent. And just most people, I think it's easier to look at. And that's what I did. But the way you did it is perfectly fine. Nothing wrong with it, guys. These problems, there's more than one way to approach these problems. So what I did was I divided both sides by r, and that cleared it. And then from here, I divided both sides by cosine. And I did that because I wanted sine over cosine, which became tangent. And then same thing that Chloe did. I did the, in this case, well, arctan both sides. And basically, you want to know at what angle does your arctan or your tangent equal 1. And at pi over 4 and 5 pi over 4. Y divided by x equals 1. So there's the answers there. You did it slightly different too. And Emily, the way you did it, did you get the same answer?
Yeah, I'm just saying I only did it differently in the way you got to sine theta over cosine theta as 1. I just divided by cosine theta first, so I got r sine theta over cosine theta, and then I divided by r because it was just easier to look at for me with it still being there.
Yeah, gotcha. Yeah, that works. And then
Because
we
it
go
was
to the graph.
isolating it, which is what's easiest to look at.
Right, right. And that's okay too. So graphing y equals x, that's just a line. And you probably maybe even could have thought about the answer before we even got there. Because I feel like Friday we actually went over this example in a way that it graphed. So a straight line, remember, is in the form of theta equals some angle. And so theta equals 5 pi over 4. That's this portion in quadrant 1. And then theta equals 5 pi over 4. Or did I say that backwards? Quadrant 1, this portion is pi over 4 equals theta. And then in quadrant 3, that is theta equals 5 pi over 4. So that's this part of it. In Desmos, you cannot type this in to graph it. So you have to, and GeoGebra can't do it either. So you have to know that theta equals some number is a line, and that line is dependent on, well, the angle given. So there you go.
But can you graph the original line, y equals x, to see which one it falls on? I know that wouldn't work for necessarily everything, but for this, I think it would, to see that it falls on 5 pi over 4 and pi over 4.
Yeah, kinda. This is a very simple one that it's obvious. It's a slope of 1, right? And there's no shifting involved. So up 1 over 1. And that, so you're splitting 90 degrees in half. So that's 45 degrees. So if you look at your unit circle, 45 degrees is pi over 4. And that's what I was saying. Like this example right here, knowing that this is 45 degrees, you can go pretty much from this right to the answer.
Yeah, okay, that's what I pretty much thought. Thank you.
Mm-hmm. All right, let's I'm going to skip this one because I want to go on to the other ones, and we're running out of time. So I'm going to skip this. Maybe I'll throw it on Bell Work tomorrow, but here's the problem, and we'll go over it tomorrow. All right, polar to rectangular, not going the other direction. So I have 5 examples. We probably won't get through all of them. I might use one of them on Bell Work tomorrow as well. So let's do. I feel like my examples are like just going opposite of the answers we already got, kind of, at least for like number 5. Did I do that on purpose? I want to say maybe. I don't know. Let's look at number 5. All right. So we have R equals this stuff. All right. So whenever you have like secant, cosecant, cotangent, we probably want to rewrite those as one of those just fundamental trig functions, sine, cosine, or tangent. So you really want to write secant as well, one of the fundamental trig functions, and don't change tangent yet. Well, actually, we can. But what does secant become? Yeah, so secant is 1 over cosine theta. And so that's what I did first. It was I converted it to a fundamental trig function. All right, so then from here, we can actually convert stuff now. But I cleared fractions. I like getting rid of my fractions first most of the time if I can. In this case, I can get rid of that cosine. On the bottom by multiplying both sides by cosine theta, and that's how I get this. And remember, if you look over here, to go from polar back to rectangular, to get polar stuff to an x, or this polar stuff to a y, we need both pieces. We need the r and the cosine to get back to an x. We need the r and the sine to get back to the y. To get rid of tangent of theta, well, this just becomes y over x. So that's a really easy conversion right here, right? We just put y over x. But if you don't multiply both sides by cosine, well, this r is lonely, and we cannot convert r. Well, we can convert to this, but then we're going to create a mess. Then you would have, so let's say you made the choice. You said, oh, r becomes radical x squared plus y squared. Sure, we can do that. Why not? Tangent becomes y over x. Okay, we're doing good so far. But then you're left with cosine theta. We do not have a conversion that converts cosine theta into rectangular. So that means we did something wrong. And that something wrong that we would have done was just take the r value by itself and convert it to this. So just because it's on the list, it doesn't mean it's a good choice. Does that make sense? And you may not see your bad choice until you start converting stuff, and then you're left over with like cosine theta or sine theta. You're like, I can't do anything, right? Big problem, which means maybe we should kind of backtrack and try to pair that rogue cosine or sine with an r value if possible. So that's what we need to do. And that's why you want to multiply both sides by cosine theta in this case. Now from here, r cosine theta, that combination becomes x. So that gets replaced. Tangent theta by itself becomes y over x. So let's do that. All right, remember, in rectangular, what are we solving for? We're solving for y. All right, so what's our next step then? Multiply both sides by x. Yes, we can do that. And then what? Divide by 4. Yep. And now we're done. All right, questions on this problem? No, I think these might be easier. Going from polar to rectangular might be easier. All right, so this one. Let me give you, let's say a minute and a half to get a good start in this problem. See if you can figure it out. Minute and a half, ready, go. So I'm going to give you a hint. You need to use your identities to convert that sine. Well, when you get sine 2 theta in your work, you need to use your identities to convert that using one of your identities. So okay, what's our first step, everyone? Converted. Yep, convert that cosecant to sine. Okay. Now, this is what I was talking about. The sine of 2 theta. Look at your identity worksheet, your formula sheet, and I think they're called what, like double and half identities. Find the one that says sine 2 theta, and well, we need to rewrite that. If you look, sine 2 theta becomes 2 sine theta times cosine theta. So it's on your identity worksheet. Okay, next, what I see is, what can I cancel out right now? Anybody see what I can cancel out? The 2's, yeah, the 2's cancel out. 2 times that stuff over 2, yeah. Factors and factors cancel out, so I can just do that. All right, so now I have r squared equals 1 over sine theta cosine theta. How can I get rid of that fraction? Multiply, yeah. So don't be tempted to convert r squared to x squared plus y squared. And the problem is, if you do that, sine theta and cosine theta, you can't convert it, right? You can't convert it. There's nothing to convert it. Cosine and sine needs r. So multiply both sides by sine theta cosine theta. So then we get 1 on the right, and then you have r squared times sine theta cosine theta. Do you all agree that r squared is just r times r? Do you also agree that the order I multiply in doesn't matter? If I say like 5 times 1 versus 1 times 5, right? Okay. So is it okay if I write it as r squared as r times r, and then I can reorder my factors as maybe r times cosine theta times r times sine theta? You think that's okay also? I think so too. I think so too. Yeah, these are just factors. Yeah, so yeah, those are just factors. So I can, doesn't matter the order I multiply in as long as I multiply all of them, right? So I just wrote it like that, r times sine times r times cosine. And now, if you notice, in our list over here, we get the combination. We get this pairing to convert this into x and then this into y. How neat is that? I think that's pretty neat. So that's what we do. We just replace those with x and y, or y and x. And remember, we are solving for y. So what should I do? What should I do? Divide both sides by x. Yep. And then there's our final answer. These just take practice. And let me, it's just about 11. Let me get the link for everyone. If you have to go, here's the link for you.
I
want to
have
stay
a
around?
quick question.
Yep.
Why are we solving for y instead of x? Does it matter?
Because when you graph, you always, well, that's not a good example. Because that's a conic.
Yeah, because like fx equals y.
Yeah.
Okay, I see what
Yeah. Okay. Yeah, you always solve for y, and then for polar, you always solve for r. So
Okay.
yeah, if you have to go, there's the
Okay,
link. If you want to hang around, I'll work out some more examples. The recording, can always watch the recording later. So if you have to go, don't feel like you're obligated to stay. All right, let's do some more. We got 3 more examples left. Let me see. What should we do? Let's do this one. This is actually a good one because you can see that we can probably kind of get stuck here. So we got r equals 2 cosine theta plus 2 sine theta. And we know in order to get rid of cosine or sine, we have to be paired with the variable r. And right now we're not. So any ideas on what we can do to approach this problem? This one's not that obvious. Factor. So we can pull a 2 out, but does that help us? So yeah, you can pull out a 2. It doesn't really help us. Then you get 2 times the quantity cosine theta plus sine theta. It doesn't help us. We're still stuck, right? We need to somehow pair that cosine, that sine with an r. Yeah, make a wild guess, Caitlin. This is not obvious at first glance. Substitute 2 for r. We can't do that either. Yeah, we're not allowed to just say r is 2. Not allowed. Square both sides. I would say that's a good guess. And if you tried squaring both sides, you would have to FOIL it, right? And then you would just create a bigger mess. So then, like, well, probably not right. What else? So remember, your hints is we need to multiply. We need r paired with cosine and sine. We got to have r times sine and r times cosine in order to convert those. So that's your hint. But this is not an obvious choice because we usually don't do this ever when solving equations. And when I show you, you're like, oh, we can do that? Question mark, dot, dot, dot. What do you guys think? Any other ideas? Maybe we could divide both sides by r. So that might, that's kind of good, because then you could actually do that, and then you would have 1 equals 2 cosine theta divided by r plus 2 sine theta divided by r. But now the problem is you have r on the bottom, not the top, and that's an issue. So I would say that's a good guess, but also not right. But you're kind of on the right track in a way. Multiply by r. Emily has no idea. Then suddenly she says multiply by r. So yeah, that is correct. You would multiply both sides by r. Multiply both sides of your equation, your equal sign, by r. And I just show it as this. I said r times everything. It's the exact same thing as me saying multiply r on both sides. So then on the left side, what do we get? R squared. And then on the right side, so when I show it like this, all we're doing is we're multiplying every term by r. We say r times r times 2 cosine theta, and then r times 2 sine theta. That's what we're doing, right? We're distributing that to everything. And look what we get. We now have r paired with cosine and sine. I think that is excellent. Ooh, now you see it. Now you see it. Mortifying. Why didn't I think of this before, right? It's so clear now that I can see it. So yeah, Emily's right. The r sine, r cosine just become x and y. So we have 2x and 2y in those spots. And we got that there. And then what does r squared become? X squared plus y squared. Yep. Okay. Next, what do we do? So I'm going to give you a hint. Whenever you see x squareds and x's and y squares and y's, you need to get them together because we're going to have to factor them. So we're going to subtract them, the 2x and 2y from both sides. Okay. And then you also want to group your x's and your y's together. So oops. I need everyone to close your eyes for a moment. I got to cover something up underneath this that I don't want you to see yet. So everyone close your eyes. Ready, go. Close your eyes. I'll tell you when you can open them. Not yet. Don't do it. Okay, you can open them now. All right. So I got my x's stuff together, my x squared minus 2x, and I have my y stuff together, y squared minus 2y. Now, we need to factor this. Which method of factoring do we use? Complete the square. Complete the square, as Antonio says. Complete the square. Yes, you are correct. So hopefully all of you know complete the square, like the back of your hand. We did it quite a bit last semester. So remember, you are taking this term here, you're dividing by 2, and then you are squaring it. So -2 divided by 2 is -1. -1 squared is +1. So you are adding 1 to both sides. So, well, there's that one and that one. Good so far? Now, if you forgot complete the square, I would just do a quick YouTube video search on complete the square as a video refresher. I'm not going to do it today in this lesson. Something that you should all know how to do. All right, next we do the y stuff. Well, we take that -2, divide by 2, which is -1. -1 squared is +1. So we're, again, adding 1 to both sides. Okay, so now we're to this. Now we can say x squared minus 2x plus 1. This factors into the binomial x minus 1 quantity squared. And then that y squared minus 2y plus 1 becomes y minus 1 quantity squared. And then 1 plus 1 is 2. So by looking at this, we can definitely see it's a circle with a radius of radical 2. So if we were to, I don't have it graphed out on the next page, but if you were to type this in, and then you were to type this in, you would get identical graphs. It would have a horizontal shift to the right 1, a vertical shift of up 1, and a radius of radical 2. Same thing as this one. And now we're done. You should love complete the square. It's very useful in a lot of situations. All right, let me see. Trying to see if there's one more that we should do. Let's do number 8, and then I'll save number 9 for bell work tomorrow. Number 9 is pretty easy, actually. Number 8 is not so obvious, so we'll go through that one together. All right, so theta equals 3 pi 4. So think about kind of going backwards from that problem that we did earlier. So what should we do? So think back to that last problem involving that answer. We're just going backwards. So don't use a unit circle yet. We can't do that. We have to do something first. Not multiply. So I'll give you a hint. We want, so that theta by itself, we need to get rid of that theta to make it something else. Well, we can't subtract theta, then we'll just have a negative theta on the other side, and that just, well, doesn't make sense. Flip and multiply doesn't do anything. No. Remember this problem, we're just going backwards. So think back to the other problem a while ago. Let me go back to it. Maybe if you need to see it, since maybe a lot of you aren't very good at taking your own notes. Yes, that was a jab because you need to start taking notes. So looking at this problem, we're just going backwards. What do we do to go backwards? Yeah, we tan both sides. Mm-hmm. Yeah, you are tanning both sides. That way you have tan theta equals tan of that angle. I think a lot of you are tired. Seems that way in chat. Sarah, me and you both. All right, so tan theta equals that. And this goes back to the last unit, tan of 3 pi over 4. So this is asking you, what are the x and y values at this angle, right? So at 3 pi over 4, you go there, you pull out the y value and the x value. Remember, tangent is y over x. So we unit circle, we pull out the y value, which is rad 2 over 2. We pull out the x value, which is at negative rad 2 over 2. And then we have to simplify that fraction. So that's pretty easy to see without typing anything in. We know it's -1. And then multiply both sides by x, and we're done. These take a lot of practice. I strongly urge all of you to make sure you go through these modules and work these problems out. All the practice problems. You need practice. These don't come easy. All right, so I'm going to stop here. We do have this example, and I'll just use this example tomorrow for bell work, number 9. And then I will use, let's see, number 4. So 4 and 9 I'll use for bell work tomorrow, going over those.
You had one more
Hopefully
bell work as
this.
well. What do you want to do with the other one?
What number? So that's number 9, and then
Keep going. You had one more. I think it was 2 or something. Nope.
no,
Okay.
no,
Maybe
just
not.
just 4 and 9. So again, I'm going to paste the link to the slides if you'd like them, and I'm going to stop here. So thanks for hanging around, and as always, I hope you learned something.